attendance today and low on Twitch. Strange. Like, I assume a lot of your classmates are working on the homework, but explicitly said this is homework help lecture, so this is the place to be if you're working on the homework. Anyway, I got just a few slides on polling. We'll get through this fairly quick. I have some other content prepared to help with the homework, but I'd rather take questions, anything that's out there that is a burning question. I'll be watching the Twitch chat too, for those of you on Twitch. Or if you're live and you just don't want to raise your hand and shout it out, go to Twitch and comment there. I'll be watching that. So any questions you have, especially as it relates to the homework 4, as you're getting that one wrapped up, I'll take those questions and give any explanation that I didn't cover as well in class, something that didn't gel with you very well. We'll talk about it. If there are no questions, I'll go on autopilot on my content that I have prepared. We'll still fill up the 50 minutes. Bless you. All right, so let's wrap up these slides on polling. I very quickly showed it last time. Very quickly talked about polling on the chat website. So the question we had is, if somebody sends a message in chat, how do we get that message? So normally we would have to have a page reload or a refresh button or something. With Ajax, we can send a new Ajax request to be able to get that chat, but how is that Ajax request itself triggered? Do we have the user still push a button like I had originally? The first version of the site we saw, there was a button to reload the chat. It sent that Ajax request to get all the chat history, got the response, and then reloaded the chat. So we can do that, and that's fine, but it still takes a user action. So do we expect our users to sit there and mash that button to always get the most recent chat? I think that's a little unrealistic. It's not really a good user experience at that point. So this is where we introduce polling. Polling is using some JavaScript to send that request at fixed intervals, basically having our JavaScript mash that button for us. So we set up this polling using the setInterval method. This exists in JavaScript. It's in every browser. We do setInterval. This takes a function and a number of milliseconds, and then calls that function every time that many milliseconds passes. So for this, we have 1,000 milliseconds, so 1 second, and the get messages function, which made that Ajax request to get the chat history and then processed the response and loaded all that response onto the page. So every second, we're going to send that Ajax request, get all of the chat history, and then render it to the page. So now instead of the user mashing the button, our JavaScript is mashing the button. Once a second, clicking that button effectively, sending the Ajax request and getting new chat history. So this gives us more of the realistic interactions, a more usable chat app. Before we had this, our chat app was basically unusable. Like it was functionally there, it existed, it was a thing, but it wasn't something anybody would actually use to chat with. That's quite prohibitive if you have to refresh constantly. With the polling, now it's usable. We can actually chat with each other and see each other's messages as they come in with at most a 1 second delay. So this is nice. It's easy to implement. It was just one line. You can call this at any time as long as be careful to not call it multiple times. If you call set intervals twice, well, now you're going to get 2 calls per second. So the example I did with the chat app, I put this in the onload of the body. So as soon as the page loads, I start the polling, and then I know it's only starting once, and I'm polling the whole time the site's there. You can also put it in your JavaScript outside all the functions. Your JavaScript will be ran as a script as it loads. So if you put this in that script itself, your functions will all be loaded in, and then set interval will be called, and it'll start that interval. That's a little more risky because you have no guarantee that your entire page loaded before you called that function, before you called set interval. So I like to do it in the onBody, onload for the body. Or you could do onload of the body, have that call some initialization function that ends up calling this and does some other setup if you want more setup beyond that. We have choices here. But somehow getting this called when the page loads will get us there. We have some limitations here, though. We have this trade-off of where do we set the interval? How long do we wait between these requests? So the longer the wait, we have this downside of, well, users are waiting up to that amount of time to get a message. If somebody sends a message with this setup, other users are waiting up to a full second to see that message. For chat, maybe not that big of a deal. We can get around that. We can live with that. If we want to decrease those loading times, we want to say set interval of 100 and have this go 10 times a second. Well, now we have to worry about network traffic, server load. Our server has to handle all those requests. 10 requests per second per user. Once your user base goes up quite a bit, it's going to be a prohibitive load on your server. So there's trade-offs here: performance versus server load versus bandwidth, and all the resource usage. And then the client is processing all those requests too. Depending on how we have it set up, that might take a lot of their CPU and a lot of our CPU, a lot of our processing power. So it can get prohibitive if we need very responsive usability. This is where something called long polling comes in. I'll talk about that in just these few slides. I'm not going to require long polling on any homework assignments or any project or anything. We're going to, just to flash forward, I have it in one of these slides, but we're going to end up using WebSockets to solve this problem. But I want to talk about web polling because it still exists out there. It's actually a pretty common solution still. So let me talk about what this is. So this is where the server gets a request, gets an AJAX request for new content. And if there's new content to be served, to be viewed, it responds to that request with the new content. Simple enough, straightforward. If there's no new content, so in our chat app, somebody sends this AJAX request for the chat history, and there's no new messages to be read, the server hangs. It just sits there and waits and waits and waits and doesn't send back the response. So from the browser's end, it sends a request, and it just has to wait, and you'll see the loading still up in the tab, depending on how it's set up, I suppose. And it's going to just sit there and wait for a response. And then if there's any information to send, so somebody else chats in the history, as soon as the server gets that chat message, it's going to respond to that request immediately. So we can have immediate feedback, just plus network delay, for those messages. So as soon as somebody sends a message, immediately respond to that request. The client gets that response, processes it, adds it to the chat history, and then sends another long pull request. Then the server is going to wait on that one until there's something to be read. And then these will time out. There will be some timeout, like 30 seconds or so, or 10 to 20 up on the side. It depends on the server, just how everything's set up. But there will be some sort of timeout. Okay, the server says, I've waited a while with this request. I haven't gotten anything. Let me just respond with nothing new to send you. And then the client gets that response, nothing new, sends another long pull response, or a long pull request. So in the end, we get, for each client, there's always a long pull request waiting at the server that the server's just waiting on, and it's going to respond to those long pull requests whenever there is information, new information available to send to all these clients. It's going to respond to all those requests. So the server's just hanging on all these things. So we get real time, what I would refer to as real time in this course. It's real time, it's immediate plus network delay. That's what we get with this setup, which is what we want. Now we're not worried about, okay, my interval is a second, so they might be waiting a second. No, now they're just waiting whatever the network delay is, whatever our ping, well, not quite our ping time, but whatever that network delay is, that's what it's going to be now. This can go way wrong if implemented improperly. If you run this on, say, an Apache server, and you have one thread per request, and most of those threads are just sitting there hanging, doing nothing, you're going to plug up your computer real quick. Your server is going to run out of processing power. Not that it's processing so much, it's processing nothing, but if you have 1,000 users, 1,000 threads, all long pulling, 1,000 threads just sitting there doing nothing, but using up memory, having their own program stack, having their own memory allocated to them, it's going to jam up your machine real quick. If you have some lightweight threads or some green threads, there's a lot of different names for them. But if you have concurrency without each request requiring its own thread, then this can be very efficient. You can get away with this. If each one of those requests that's hanging requires almost no processing power and no memory allocation, then this can be a pretty effective method. Yeah.
Will browsers do something like this in the background by itself?
Yeah, no, continue.
Because I'm running into this, seems to be like a legacy bug in all of my homeworks, where when I open up I have a Band-Aid fix for it so it doesn't get in the way, but after the page loads, my server receives like almost like an empty request, and it just waits on it.
That might be specific to your app.
Okay.
The browsers won't automatically long pull. It'll have to be built into the app itself.
Okay.
Like the app will be set up to do long pulling.
Okay. I didn't know if maybe that was a common thing.
When I see that, the first thing I double check your content links and make sure you are sending exactly that many bits. If the content link's off by a single bit, you can see behavior like that. Beyond that, it'll be digging into the specifics of your setup and seeing it. So like I said, we're not going to do long pulling in this class. We're going to use the more modern solution, WebSockets, the newer protocol that solves the same problem, but in a cleaner way. You don't have these hanging requests. I mean, I guess you kind of have the similar thing, similar setup in a way, depending on how you look at it. But it's a more modern solution, more modern protocol. That being said, there are still a lot of major websites that do use long pulling. Long pulling is still a very popular solution. So when I say WebSockets is the more modern approach, I don't mean like that's the new thing, everybody uses that now. Long pulling still has a home in many, many major sites. It has its advantages. The big one being compatibility with old browsers. So you have a website, you don't want to restrict any users. Anybody using Internet Explorer still, I mean, those people still are out there, they still exist. You don't want to restrict anybody from your site. You don't want to say, hey, if you want to use the site, update your browser. Your user might not even know what update your browser means. It's just a reality of web development. Those people exist. And depending on their architecture, maybe long pulling is just the right solution for a lot of sites. But you'll still encounter this if you go around the web. I was trying to find an example. The only one I had was, the only one I found quick enough was Google Docs. Google Docs, Google Sheets, all those. They use a form of long pulling, but they're not using HTTP1. I believe they're using features of the newer protocols. They're using the Quick protocol for those, I believe. I think they're using a feature of that new protocol. So I wasn't able to show it in the browser the way I wanted to. But you can still see, you can go to Google Docs and see these requests that take tens of seconds to respond. And you'll see those every once in a while. Once one ends, a new one begins. You'll see some form of long pulling there. But of course, it's Google. They have very complex technologies and architectures. Just at the time I had to look into it, I couldn't tell exactly what they were doing there. But they're doing some form of long pulling. So you can see this on a lot of sites. And it's interesting just checking out sites and seeing which ones do long pulling. Because when I first learned about WebSockets, I just assumed, oh yeah, everyone's using WebSockets now. A lot of major sites don't.
Would they use it for like checking your speed? Because you said like Google has its own global network. So would they be long pulling for your speed to make sure that the network in your area is good?
Not necessarily. They can find that out by all the other requests too, but they have their reasons to use long pulling. One of them is the browser compatibility, but I'm sure there's a lot of engineers there who know more specifics, more reasons why they do that. I just am not in those crowds right now. But they have their reasons to use long pulling. I believe Facebook does too. I did check that one once, but I just didn't feel like going to Facebook during lecture and showing that. But I believe they do long pulling as well. And the one I do know that doesn't use long pulling is Twitch, which does use WebSockets for its chat, and then some form of AJAX requests to get the streams, to get the actual content. So they're using kind of a mix of things. And I feel like I always end up at Reddit for these examples, but if we check out Reddit, we can at least see the AJAX requests. Whenever we see these requests of type XHR, that's our AJAX request, our XML HTTP request, that object that we create, shortened XHR, if you see that in the network tab, that's an AJAX request. So the new Reddit has this infinite scroll. You can see since I've been here, all these loaded while I had the page loaded. We haven't seen any AJAX requests since I opened the page just now. But as soon as I start scrolling down, that infinite scroll is going to kick in. It's going to make all those AJAX requests as I'm scrolling to keep loading the content as I scroll down the page. This is how those infinite scroll sites work. They're just, as you scroll down, looks like we need to get more content for this user, make the AJAX request. So when the page first loads, you're only loading the first few things that will be displayed. Anything that's displayed on a screen full, that'll get loaded immediately, and again, those faster reloads, and we can see when we refresh, you can see the page loads, and then the content slowly loads. This is common in all the sites. We can see that exactly. We get all these XHR requests. After the first page loads, after the structure of the page loads, all the content loads through AJAX requests. So I get a very quick page load. Well, I don't know if I'd call that very quick, but 2.5 seconds. It wasn't exactly very quick, but we get a quick page load, and then looks like about 7 seconds before the majority of the content loaded. And we do have, are these AJAX calls, or are these long polls? Oh, those are just pictures. Pictures that are taking a while to load. So we can see those AJAX calls in the browser. I might as well show Google Docs. I do have it open, but it's just not as cool as I had hoped. It's not as clear as I had hoped, I should say. So if we watch this long enough, we're going to see the next long poll request that's made. There it is. And we can see these things taking a long time to respond. Well, not quite those ones. Taking a long time to respond. This is the one. Oh, we might have to wait a bit to get one. There we go. Yeah, 12 seconds. So we're getting up there in the request. This request is left open. I believe with this protocol, the server can send partial information that's processed and then still keep that same request response open. I believe that's what this protocol is doing for them. So they can kind of get the effect of WebSockets without having the WebSocket itself. They can do that in their new HTTP protocol, baking WebSocket features into that. I'm pretty sure what they're doing there. All right, any questions? Nobody has a homework question yet. That's the end. That's what I want to talk about with polling and long polling. So we're in the homework part. Who's got homework questions? You just want to see what I've prepared. See that stuff first. Seeing some head nods. All right, let's take a look. So I had office hours yesterday, and almost all the questions were just about the same thing. So let's clarify what's going on with this, with reading this file. So we have this multi-part request coming in, and it has this binary, these bytes for an image somewhere in the request, and you got to do some string parsing to be able to get that request, to be able to extract that information, those bytes for the file, and then save it to disk. You're all aware that this is the task that you're faced with, and from office hours yesterday, from talking to Nick as well, seems from his office hours, sounds like this is where the confusion, I shouldn't say the confusion, but where the difficulty lies. When I first pulled up the assignment and said it might not seem too crazy on the surface, but there's a lot of nuanced points that are going to trip you up. This is one of the ones that I mean. This is a tricky one. this is tough. So we talked about encodings a bit, and I just want to reinforce this and talk about what these encodings mean now that we're applying it to something a little more tricky. The solution to this is in all the content that we saw, but it all has to come together in just the right way. So, and I really like this because it's going to really reinforce what all that encoding stuff was all about. So let me do something real quick here. I have this image in this directory, just the Twitch icon, and I have this quick little program to show an example of what I want to talk about. So I have this function, copy file. It's going to take two file names. It's going to read the first file name and write that contents of that to the second file. I'm going to read this file in byte mode. I'm going to write in byte mode. So this is what we want in our web server. We want to just take these raw bytes of the image and just shove them into a file. Getting to that point, I know it's tough, and we'll talk about that too. But this is what we would want to happen. We get some bytes, then we write those bytes to some file. And we can run this. New image, well, I already had that open, but just call it copy.png, just to show that this is doing what it's supposed to be doing. And I can see a new file here, exactly the same bytes, it's exactly the same image as I had before. Byte for byte, exact image. So that's how we want this to work. But what if somewhere along the way, oh, what am I doing? Call the other one. What if somewhere along the way we decoded this? For those of you not using Python, the decode is going to take bytes and decode it, defaulting to UTF-8 as the protocol, or as the encoding. And encode is going to do the opposite. It's going to take a string and encode it as bytes, by default using UTF-8 as the encoding. So what if I do this? I have my bytes that I'm reading from the file. I'm decoding it as UTF-8, and then encoding those bytes and writing it back to the file. Now we should get right back to the bytes of the file, right? Of course we're not, or else I wouldn't be talking about it. We actually get an error in Python. Not all languages are going to give you an error for this. Some languages are just going to try its best with what you give it and trust what you told it to do and just try to do what you're doing. Python does give us an error and crashes. It says, hey, this isn't Unicode. This is not UTF-8. This byte sequence, I cannot decode it as UTF-8 because these are not UTF-8 bytes. These are bytes for an image, and that image is not encoded using UTF-8. This image is encoded using PNG, using PNG's encoding. So when we try to decode this, we can't. If a language does try, what it's going to get is a lot of errors. It's going to have a lot of byte sequences that are not valid UTF-8, and it just can't turn them into characters. So you get a lot of those like boxes with the question mark, those characters that just aren't really characters. You see the same character hundreds of times when you print to the screen. If you print your file to the screen, those are all your encoding errors because this is not encoded as UTF-8. So we can get rid of this error itself. Well, if we say, no, Python, just do it anyway. If I use string and cast this as a string, we actually don't get that error. It's going to try its best. So let's run this again. That worked. We copied the file. Here's where I want to change the file name. So we copied the file. If I go to the one with the PNG extension, just says, there's an error. Can't read this image. It's not an image. By the way, the file extensions, if you haven't seen this yet, if you haven't heard this yet, file extensions don't really mean anything. We don't even have to use a file extension. I just created a file without a file extension. File extension does really two things for us, for the most part anyway. There are some nuances. It helps us see what the file type is. If I see .png, I know I'm looking at a file that represents an image using the PNG encoding. And two, it tells our operating system what default program to use to open that. When I have this PNG file, or an icon file, or a Python file, the file extension is telling, in this case VS Code, what algorithms it should use to try to render this thing, to try to display it to me. But the file extension doesn't mean anything. Copy and copy.png have the exact same bytes in them. We wrote the exact same bytes to both these files. One of them we just named without a file extension. It's no big deal, it's possible, it's something we can do. File extensions really don't mean anything. And we can see that when we're sending images over the internet, there's no file extension on those, it's just a bunch of bytes. It's just a bunch of bytes in the body of a request or response. There is, for the images that are uploaded, we do get that file name, but it doesn't really mean anything. When you served your file, you never gave an extension to that. You used content type to give the browser a heads up of, hey, this is what I'm sending you. But there's no file extension there. So anyway, let's go to copy. We can see a whole bunch of bytes of that. Those bytes decoded, trying to pretend it's UTF-8, and then re-encoded using UTF-8. And we get all these bytes. And we're going to see a lot of nulls here. No, not as many as I thought. At least, well, not as many as I thought. But it's garbage. It's not good data. If we copy this file in a good way, but without the file extension, we can see the bytes that we're expected to get. And we're going to get those, can't decode this as UTF-8 because it's not UTF-8. We're going to get that character a lot, and sometimes we just happen to have valid UTF-8 characters, but it's not meant to be UTF-8, it's just a bunch of garbage when it's displayed as UTF-8. But these bytes are very different than these bytes. We can tell it's rendered way differently. These are different byte sequences. When we converted this to a string, as soon as we did this, we destroyed any of the PNG encoding that we had, because we have no idea what those bytes are actually going to be representing when decoded using the improper encoding, in this case UTF-8. We can't do that conversion. So we have this problem of having a mixed request, which is very common. I mean, that's the whole idea of multi-part. We have this request with different encodings throughout. We have the headers, which are going to be ASCII encoded. We have the boundaries and the headers of each part being, again, ASCII encoded, but then we have the image being just bytes, being PNG encoded or JPEG encoded, icon encoded, whatever file type you decide to support. So we have different things, and we're getting this all as one big sequence of bytes. Parts of it we can decode using ASCII or UTF-8. Parts of it we can not decode unless we're writing PNG stuff or image rendering stuff. We're not doing that. Parts of it we just have to preserve as bytes and write to a file. So instead of using the string parsing stuff, the temptation is always convert the entire request to a string, find the header for content type, find the boundary, append the 2 dashes to the beginning of the boundary, and say body of the request dot split on this boundary with the 2 dashes in the front. That's what our temptation is to do. That's what everything tells us to do, everything we know from working with strings like this. But we can't do that in this case, because as soon as we convert that image to a string, we lose the encoding, the image is destroyed, and we're not going to be able to read that image once we save it to disk. So how do we handle this data when we have parts of the byte array with different parts with different encodings? So let's talk about it with good old hello world, because I'm lacking a little creativity today, in most days. Hello world speaking of lacking, I use a lot of my creativity. I just use it up on other stuff. So speaking of the Project 1 document, the Phase 1 document is up. So it's on the course website in the project portion. It's that's what I was busy doing last night, finishing that up. So if you want to look at the requirements, take a look at them. If we have some time here, maybe I'll open it up and walk you through it. But all right, so we have a string hello world, and we want to find some substring of this. I'm going to use WOR. So we want to find WOR in this string. Now, of course, we would do hello.find to find. That's going to give us some index. We'll print I, and we get 6. 0, 1, 2, 3, 4, 5, 6. We get this index, the index of the beginning of that. So you can imagine this being the boundary, WR being your boundary, the hello world being your request. Obviously, it'd be more complex, but to give you the idea of what's going on here. So that's what we would want to do find that boundary. Simple enough, but we're in the world of strings. What happens when we can't do that? So what happens when this is encoded as a byte array and we want to do the same thing? Well, we take our boundary. Why am I not calling this boundary? Well, in Python, we do the same exact thing. And we get 6. So we, instead of finding on strings and saying, give me this character sequence in this string, find it and give me the index. In Python, JavaScript, any of the languages you're using, there's a way to find a sub-array of bytes in an array of bytes. So we want to stay in this world of bytes. When we extract our boundary and add that dash dash to the beginning, take that string, encode it into bytes, and then look for that subsequence of bytes in your request without converting your request into a string. So work in the world of bytes. Once you have the parts of your request separated, for example, we can also do this and find that blank line that separates the header from the body, and also once we separate the boundaries and find the parts of our multi-part, that's going to separate those subheaders of each part with the body of each subpart. So we find the boundaries, separate the parts of the boundaries, get that header lines, new line, blank line, and then all the bytes for our image. Find that new line. Everything after that is going to be our actual bytes of the image. And everything before that is our content disposition and content type, whatever, and any other headers that we have. So if we look for that boundary, work with the indexes, and then do subsequence. So here we would do, maybe we want everything after that boundary. Let me go back to, maybe I want everything after that boundary. Ooh, I haven't done this in Python. Hello bytes. I got to remember how Python works. Hold on. I think I'm getting there. I didn't realize how long it's been since I did Python. Plus length, colon. It all comes back though. Print. And I should, if I did all this right, I should get LD from here. Bless you. And I get LD as bytes, and then I could. Yeah. No, decode. What am I doing? Why doesn't that want to autocomplete for me? I can get that as a string by decoding it. So I can extract the subarray of bytes that contains my headers, decode that using UTF-8, and then take the bytes after that new line, but before the next boundary, take that subarray, slicing my subarrays, take that as the bytes of my image and save that to a file without parsing it, without decoding it as UTF-8. Yes?
So when we get that initial post request, should we not convert to string in the first place?
Not necessarily. So should you convert to string when you get the first request? I wouldn't. If you do, I mean, it's not the worst thing, but once you convert that to a string, you've corrupted some of the data. So some of that data you can't use as a string. But if you don't want to ignore the body, like as long as you're preserving the original bytes and then converting it to a string, doing some string parsing to parse out your headers, use that to get all your headers, but then still go back to the original bytes that you received. That's not the worst thing in the world. Personally, I like to find the blank line. I'll look for this. First time I get a request. First time I'm seeing it, it's not buffering or anything. I get a request. I'm going to look for this, take everything before that as a subarray of bytes, and then decode that using UTF-8. So I'm not even messing around with the body at all for that first request. You can look for this. The HTTP protocol guarantees there's a blank line after all of the headers. So you can look for that blank line. If there's no body, that blank line is still there. You can look for this line, this blank line, get the headers, decode those, parse all your headers. Is this, and do your checks. Is this a post request? Does it have a content length that's not 0? And then start doing your checks. Okay, how many bytes did I have after that character sequence, that byte sequence? Do I have enough bytes to satisfy my content length? If not, start buffering and go that way. And then once you get the whole request, depending on what it is, okay, now that body, how am I handling that? Do I handle it as a byte sequence? Can I convert it to a string? If the content type is plain text, UTF-8, I'm converting that to a string and just handling it however we handle it. Just like we did the form for Objective 1, you can do that. You can just handle it all as a big old string, no big deal. But once we have the image and we have these mixed content types, that's where things get tricky. And it's what really makes the internet a thing. We're always just communicating bytes, and then we have these ways to figure out how to interpret those bytes as they come in. Data.
Sending an image and some text and several things.
Yeah.
It's going to be terminated differently.
When you're getting the multi-part, or when you're sending, which one specifically are you talking about? When you're sending an image?
When you receive that.
When you're receiving an image as part of a multi-part?
Yeah, but it could also have text in it.
And it can also have text, yes.
So.
And that's where we're leaning on our protocols pretty hard here. We're saying we're going to assume and hope that the browser sent this in valid HTTP, which all the major browsers, of course, are going to do. And we're going to lean on that pretty hard. So first, we read the content length. Even when we have all this mixed stuff, we have just a bunch of bytes for the body of the request. Some of them are encoded with UTF-8, some of them are encoded with PNG, some of them can be plain text. They can be all over the place with encodings, but they're all converted to bytes before they're sent over the stream. So the total number of bytes of everything in the body of the HTTP request is going to be included in the content length header. So you read content length, and then you don't even care what type of information you're getting in the body. You just read it all. So like every character in the body encoded, in the boundary is going to be ASCII anyway. So the number of characters there, each is a single byte. The blank lines are going to be 4 bytes. The image itself is the size of the image in bytes. All of that adds up, and that's the total content length. So when we read the content length, all of that information, that's how much information we should expect as the content length, and we'll assume the browser's acting in good faith and actually has that number of bytes all summed up after encodings and after all that. Once we get that, then we're looking for the boundary. That boundary is going to be the separations of each one of those pieces. For the image upload, you just have one piece, but it's a boundary, starting with the boundary, ending with the boundary. The boundary has that leading dash dash, and a trailing dash dash at the end, which you can mostly ignore, at least for this homework, but you should account for at some point. So we look for those 2 boundaries. Everything in between those boundaries is going to be formatted very similar to the original request. We have headers, and then we have a blank line, and then the body. So everything from that blank line to the dash dash boundary after that, everything in between are the bytes of your image. So you know that that's encoded with PNG. Everything from the first boundary to that new line is going to be the header. So you can parse that as ASCII or UTF-8 just by default. So
how do I make the distinction that that section of what I parsed those bytes is what contains the image? So you can't compare the string version of that with what's in there. Like how do I?
Yeah, let's talk about that.
Like once I do my splits, I have a lot of different elements from that split. How do I identify that this one contains bytes from an image and then be able to identify that and start the read from that?
Let's run this. No, just do it. Oh no, come on. Why? I'm not going to debug this during lecture. I don't know what's going on there. But it's based on the protocols. You're looking for that boundary. Every time you find a byte, a subarray of these bytes that match dash dash and then your boundary. So you take that as a string, convert it to encode it as bytes, and look for that byte array in the body of your request. Every time you find that, you know you have a division point in your. Yeah, you can have multiple of those. So yes. So in the headers of each part, you're going to have a content type, and that's going to tell you how to decode it. So what I was trying to show here is when I do upload a PNG file, that part of the multi-part is going to have content disposition with some information and content type image/PNG. If it's plain text, it'll say content type text plain. So that content type is going to tell us for each part. I was trying to show it. I wanted to show it exactly like. But you'll read that content type. For homework 4, you can shortcut that a little bit, kind of limiting the difficulty of the assignment a little bit there. The image form, you are only uploading an image, so you can assume that the one part that you do find is the image itself. But when you do have more complex forms, name, address, image upload, a PDF upload and a profile image, and when it's more complicated. What's that?
For now, just do the 1.5. Right?
For now, you can just do the 1.5.
For what I was doing is to handle like future complications. I was sending a file with a password.
Yes.
That I don't have to expand it later.
In that case, you would read the content type. Content type is image/PNG, then you know you got your bytes for your image. Yeah.
How should we handle file with the same file name? Do we replace the old one or just add like a one?
So you should come up with your own naming convention is the way I recommend this. You can add the one like you're talking about. I recommend just come up with your own file naming convention. So each time you get an image, don't even read the user's supplied file name. Just completely ignore that. Don't use it at all. And then start saving them as like the first image you get can be image 1. The second image you get can be image 2. Just have an int that keeps incrementing every time you get an image. Then save them like that. And that helps you with your templating as well. If you don't want to go to the directory where you're saving these, iterate over all the files to get all the file names, you can just look at the current index. Okay, well, I'm on index 10. My next image is going to be 10. So if I loop 1 through 9, I know those images are going to exist. So with the clean naming convention, you can save yourself some work down the road too. Can you use a question about posts? Is it meant to redirect the user or just update something? You can have a response with a post. It depends what you're using the post for. For my chat app, I was using posts with AJAX requests, where the user was using the AJAX post request to send their chat message. I wasn't really interested in the response. We do still have to send one, or else the client is going to hang, and it's going to be expecting that response. So I was still sending a response, but my response just said, hey, I got your message. That response can just be empty as well. There doesn't have to be anything in that response, but you got to send something to satisfy the browser. We could also send a lot of information, or as we were doing earlier in the semester, we could send a whole website and have them say we want a form to trigger a page load. The response from the post request would actually be more HTML, an entire HTML page that would be rendered in the browser. If we're sending an AJAX request, it won't be rendered automatically. So it's up to us what we want, what behavior we want from the response to that post request. But we got to send something. Oh, somebody answered. I should have just read the answer. So for homework 4, you don't have to take into account server resets. Again, to manage the difficulty and the scope of this assignment. If nothing works after a server reset, it's fine. It should, but I didn't put that explicitly in the doc. I'll stand by my documents. If I left something out that I just wanted in the assignment, but I didn't put it in the doc, I'm not going to hold you accountable for that. So I didn't put persists after server restarts. I actually never put that you have to save. This is kind of an oversight, but I'll stick to it since that's what the doc says. I never actually said that you have to save the files or save the images to files. And some of you asked me, can I just store them in data structures? I mean, I'll stand by my doc. I didn't specify, so I'll allow that. You just want to store them in a map of name to byte array. It's kind of silly, but if it gets you through the assignment, it gets you through. You're still doing all the encoding and decoding and all that stuff. So I'd still be satisfied from the HTTP, from the web perspective. File I/O, I mean, you've done that in other classes. I don't have to retest you on that, I guess. I don't know. All right, we're over time by a minute, so let's get out of here. Good luck, everyone. See everyone Monday. Have a good weekend.